What we'll do first is we'll do a basic revision of this. This is what we studied last time. We studied what recursion was. Recursion was where basically we were taking a bigger input, we were making it smaller and smaller. In a sense, we were trying to make our code simpler. We used a method called what I like to call the hypothesis based condition induction method, wherein we came up with a hypothesis of what we wanted our function to do. Then we made that code smaller and tried to induce something for the value that was left out. So for example, like we'll just go through one example of this to remember what this was about, and then we'll maybe move on to the new codes that we're going to study today. For example, when we wanted to print a 1 to n, we decided on hypothesis that I wanted the function to go from 1 to n. If it's for n, and from n 1 to n minus 1 if it is for n minus 1. The base condition here is basically the smallest valid input that we wanted it to stop when n was equal to 1. And our induction step is basically, once we have function of n minus 1, how do we convert it to the function of n? Here it was very easy, we just simply had to add the n in the end. So this was just to remind you guys what this method was about. We did quite a few problems related to this, but today this is not what we're concentrating on. Today we're concentrating on a new method which is going to, first we'll do another example of this IBH method. It's a very common problem. It's called Towers of Hanoi. You guys must have heard it a lot of times, but the thing with this question is that 90% of the people can write the code for Towers of Hanoi, but very rarely are they able to understand the logic behind how it works, that is the logic behind what actually is happening in this question. So that is what I hope to change with taking up such a common topic. I was very confused about whether to teach it or not, because 90% of the people can write the code, but then I thought that if you guys are able to understand how this code actually works, it will be really simple for you to grasp how recursion works. So what the problem statement is very easy. You have 3 towers, like you can see here. You can call it the source, the destination, and the help tower, or anything you can call it, ABC, whatever. Your target is that in the beginning you have n number of disks. In this example there are 3 disks. You have n number of disks on your first tower, and your end goal is this, to move all those disks to the third tower. Now there are certain conditions of what you can do. The first condition is that only one disk can be moved at a time. That means that you cannot pick these 3 disks up together and place them here, because there is no point of the question otherwise. Okay. The second condition is that you always take the uppermost disk on a stack. That is, if you want to move any disk from A over here, it has to be the red disk. And in this, if you have to move any here, if you see, if you have to move any disk from here, it has to be the white disk. So it always has to be the topmost disk. And the third and the most important condition, if I may say, is that you have to arrange the towers in descending order again. That means that the bottommost tower should be the largest tower again. It should be followed by the smaller one and then the smaller one. So basically you can't just pick it up and invert it. Okay, so this is what the problem statement is. I'm sure a lot of you guys know this problem, but try to follow the method that I'm going to talk about here, because I'm pretty sure it will help you understand what is actually happening. Okay, so if I move on to this, my hypothesis based condition induction method. Okay, so here let's just understand what the variable means again. N here is the number of disks, S is the source tower, D is the destination tower, and H, if I may say, is the helping tower here, which you're using to move the disks. So your hypothesis is that your solve function will actually print the steps and will help you move the n number of disks from S to D. So if I, instead of putting an n here, if I put an n minus 1, you will basically be moving n minus 1 disks from the source to the destination. Okay, so if you, if I may say, if I can show you this here, what solve of n is doing is it's going from here, this top left piece of picture to this step 7, that is, it is arranging it entirely here, and if I have to do the same thing for n minus 1, it is essentially this, which is 3. That is, you have moved the top 2 discs in the correct order, and the task that is remaining to do is that you have to place this disc at the bottom. So how do you place this disc at the bottom? Like, if you think about it, it's extremely easy. You do this in the induction step. How does the induction step work? Here you have this, that means you have performed solve on n minus 1 discs. Now you actually have to, your end goal is this. So you actually move the third or the nth disc from the source to the destination, and then you have already understood how to solve n minus 1. So you solve n minus 1 again for these 2 discs and place them here. So if I am being clear, I'll repeat once. Basically how this method works, how the recursion for this code works, is that you essentially solve for n minus 1 discs, which has been solved here. After that, after you have here in step 3, after you have solved for n minus 1 discs, you move the bottom disc from the source to the destination, after which you solve n minus 1 discs again, but instead of putting them in the help tower, you put them in the destination tower. So this is the concept of towers of Hanoi. I'll keep checking for doubts on Teams if there are any. Yes, the meeting is being recorded. The recording will be available to you soon. Okay, so moving on, we've understood what the problem statement is. And we've understood how the hypothesis works. Let's move to the base condition. The base condition, as I said, is always the smallest valid input. In this case, you have to move one disk. If there is only one disk that you have to move, you can simply take it from the source and you can put it in the destination. So that essentially here is your base condition. Now that we've understood this, let's start coding this from scratch, and let's see if we're actually able to figure out, if you're being able to understand how this problem works. I know that this code is something that you do all the time, but now that you have this extra bit of knowledge of how this code works, let's see if we're able to understand each line of the code. Like, to be honest, before I thought of it this way, I was not able to understand how the code actually works. I just knew that this is what you have to do. But now that we code it, I hope that you guys are able to understand why you're writing each line of code. Again, if there is any question, please, I'm waiting in the chat box. You can always ask your doubts there. Okay, so towers of Hanoi, let's take a function like we always do. We take a function solve. I will call it, you can call it whatever you want. And there are 4 inputs: the source, the destination, the helping tower, and the number of disks. First, you write the base condition, that if n is equal to 1, that is, you have only one disk to move. You simply move that plate from the source to the destination. So this is just my print statement. You can write it like move plate from source. You can call it source or you can call it whatever you want, from source to and destination. Okay, this is just my print statement. You can write it however you want, that is not a problem. Recursion in case you guys are wondering, I'll put these codes up later for reference, so that's not a problem. And if this is done, that means if you reach this place where you have reached n equal to 1, your problem has essentially been solved, so you can move out of the function. If not, if this does not happen, now here is where you will have to pay a little bit attention to what you do. Here basically you will solve for now. Here, if you think about what is happening here, if you see this problem, for n you have to move n disks from A to C, but in the process you're actually moving n minus 1 disks from A to B, not C. That is you moving n minus 1 disks to the helper tower, after which you do the induction, that is you move the first disk from the source to the destination. So this is where this line comes into play, that you are moving from source to helper tower, not to the destination. In the process, you can use the destination tower as your helper tower for this particular problem. And right now you have n minus 1 disks. So with this line of code, what you have basically done is you have moved you have successfully been able to move n minus 1 disks from the source to the helper tower using the destination tower. And after you have done this, your last step is to, if I make copy, your last step is to move the last plate, that is move the nth plate from source to destination again. Okay, because that is what we did here. You know, I'm going to use this example for reference because it's very pictorically clear, that after you have moved these n minus 1, that is 2 towers from the source tower to the helper tower, you're moving the nth plate from the source to the destination. That is what I've written here, that I've moved the nth plate from the source to the destination. After this, again, what you have to do is you have to perform the solving for n minus 1 towers again, but here the source is the second tower and the destination is the destination tower. So this time when you write solve, you will be solving from helping tower to destination tower, which means you will essentially use source as your helping tower, and this is again for n minus 1 towers. Okay. So if you guys were able to follow what I just said, it must have made it extremely clear how this works, that is how the towers of Hanoi work, how you use towers of Hanoi, what these two recursions mean, because this is a doubt that a lot of people face. And you know, it might help you in your placements also, because not a lot of people are able to explain how this code works. Again, let's just test it. I'll take an input. If there are any doubts at any point during the session, feel free to type into the chat box. I'm inputting the number of plates. You can call your source tower 1, your helping tower 2, and your destination tower 3. And after this, you simply call for solve, source, destination, helping, and n. Okay, let me run this. Let's check it with 3. Now what we'll do is, to see if this works or not, let's put this side by side to this. Okay. The first thing that happens here is you move plate 1 from 1 to 3. Plate 1 from 1 to 3. Then you move plate 2 from 1 to 2. Plate 2 from 1 to 2. After which you move plate 1 from 3 to 2. Plate 1 from 3 to 2. After this you move this essentially again you have finished towers of Hanoi for n minus 1. Then you move plate 3 from 1 to 3. Plate 3 from 1 to 3. After that you move plate 1 again from 2 to 1. Plate 1 from 2 to 1. Plate 2 from 2 to 3, and again plate 1 from 1 to 3. So if you're being able to see, this is exactly what had happened here, and with your code you've been able to do exactly this. I hope you guys were able to understand how this code works, how you actually solve towers of Hanoi. there's another variation to this question, wherein instead of asking instead of asking for the movements that which plate is moving where, you're asked to find how many steps it needs. That is again very easy. You take a counter, you can identify it to be 0, initialize it to be 0, and then you can simply, before you do anything else, just do a counter plus plus. Actually it's Python, so you can't do counter plus 1 plus plus, you do counter plus equal to 1 here, because every time the recursion is happening, it is essentially one step of Towers of Hanoi, and then you can print the value of counter. So if you know how this code works, you can if you actually understand how this code works, you will be able to do any variation of Towers of Hanoi in any way you want. I'll take a 1 minute break here, where you guys can, you know, see if there are any doubts you have, if there is anything you want to ask, and then we'll move from there. Any doubts, so you can text in the chat box. We'll start in another minute. We'll start at 7:30 again. Okay, so this Towers of Hanoi was a question we did using the induction hypothesis method. There's another very famous method that everybody uses for recursion. It's the output input method, or you can call it the recursion tree method. It's you know, useful for questions of the kind that we're going to study right now. For example, if you're asked to print subsets of a string. So if you draw something like this, which is called recursion tree, if your input is, let me just use this only, if your input is AB, you get 4 substrings: an empty string, you get an A, you get a B, and you get an AB. How do you get these? You know, so what we'll do here is we'll try to pictorially represent how you get these 4 values from AB, after which we can you know, try to code it. I would like to mention that if you know how to draw a recursion tree, actually writing the code for recursion is a cakewalk. It's not tough at all. So let's try and see if we can draw the recursion tree for the same. So now for these type of questions which are related to, you know, substrings, or you know, something related to this, you can draw a recursion tree using an output input method, wherein you initialize your output to an empty string and your input to the whole string. What we basically do in this question is we go character by character. That is, we use each piece of character and see what we have to do with it. Okay, so for example, to make a substring, make these substring that we just, these 4 substrings that you can see here, what we basically do is we either include each letter or we do not include each letter. For example, here we chose not to include both A and B. Here we chose to include A, but chose not to include B. Here we chose to include B, but we chose not to include A. Here we chose to include both A and B. Okay, so now that we have understood this, let's draw the tree. Here your inputs are A and B. You go one character at a time. You look at A. You either not include A or you include A. So if you not include A, your output still remains an empty string, and since you've already analyzed A, your input decreases by one length, it becomes B. Then we go to the other set, that is when we choose to include A. Now that we have chosen to include A, your output becomes A and your input decreases by one character and it becomes B. Okay, so here you have two outputs, an empty string and an A, but your job is not done here because you have not analyzed the entire input array yet. So now the next step, the step that you perform after this, is you analyze B in both these cases. Here in this case also, either you choose to not include B or you choose to include B. So let us not include B and see what we get. The output here was an empty string, it remains an empty string. But since you have already analyzed B, your input also becomes an empty string. If you come here, the output becomes B because you chose to include B here, and the input becomes an empty string because you have analyzed B also. Here you choose to not include B, so you get your output is A and your input is an empty string. In this part also you chose to include B, which is why you got an AB and the input remained an empty string because now you have analyzed each character. Now where do you stop this recursion? Where do you stop drawing your tree? You can say that you can stop drawing the tree as soon as you encounter a case where your input becomes null. That is, you have no more letters to analyze. Since you have no more letters to analyze, you cannot continue the recursion tree further. Here you have, if you look at this row, you have no more letters to analyze, which is why you stop your recursion tree here. And your output becomes this, the empty string here, the B here, the A here and the AB here. Now this is how you draw a recursion tree for any question. You analyze character by character and you give it choices. Recursion is all about making the correct decision when you're giving a choice. But here what we're doing is we're not making one correct decision. Here we're taking all decisions into consideration and seeing what we get. This is how you will draw a recursion tree for such a question. Now how will you code this recursion tree? You have a pictorial representation of what you want your recursion to look like, but how do you code this? This is what we will study right now. We will understand how we are able to code using a recursion tree. Again, it's really easy. So just 1 minute and you can see. You take an input, you take an output. Okay, always remember that whenever you draw a recursion tree, there has to be a base condition no matter what method you use, because if you do not give a base condition, your recursion becomes infinite, it never stops. What is the base condition here? You can look at the tree and you can understand what the base condition is. If you look at the tree, you can see that whenever you get the output, your input is an empty string. So automatically you are able to understand that the base condition here is when your input is an empty string. So if your length of input becomes 0, you print the value of output, because you print the corresponding output and you move out of the function because you're done. Okay, now what are we doing? What we are essentially doing is we are dividing this output, not dividing, but basically we are making two different outputs out of this one output, after which we continue our analysis. Okay, so I'm going to call going from AB, going from an empty string, your output went to an empty string and an A. Similarly, from an empty string, it went to an empty string and a B here, and from an A, it went to an A and an AB here. So if you try to observe here, one of the outputs is in this recursion is always the previous output. Here it was the empty string, here again it was the empty string, and here it was an A. So if you're making two outputs out of this one output, your OP1, that is, you can call it the output 1, is always OP, and your output 2, if you can see here, is OP followed by the string that is under analysis right now. Here it is A, here it is B, and here also it is B. So essentially it is OP plus which string is under analysis right now? The first string of the input. Input. Okay, the first string, the 0th index, that is. So now you have two outputs. What you have to do now is perform the analysis further. You have to analyze further, that is, you have to do a recursion, you have to call the function again. But the thing to be noted here, or the thing to be kept in mind, is that you cannot simply call the recursion on input again, because if you notice that your input has become smaller, that is your input has decreased 1 by length. How do I decrease my input? It's simple. I just use slicing. Okay, after which you solve. What have you done? You have decreased the input length, that is, you have gone from AB to a B in both cases, and after that you have performed an analysis with an empty string also and an A also. Here you're done, you can simply return. So if you guys, to do a basic recap, we decided to draw the recursion tree till we got an input to be an empty string. We analyzed the recursion tree and we saw how we were dividing the output into two different parts and how we were analyzing the input strings one by one, and this is what we did here. Let us try to call this function. We enter a string, you initialize your output with an empty string, and you solve for input comma output. Let's see if we're able to get the output, required output. One second. Sorry, I didn't name the function. Okay, so def solve. Yeah, so let me enter an AB. You get an empty string, you get a B, you get an A, and then you get an AB. If I run it for a larger string like an ABC, you get 2 to the power 3. Since the length of the string is 3, you get 8 outputs. You cannot, like, the empty string is right here if you can see it. So this is the what I call the input output or the recursion tree method, and this is also a very common method that is used. You draw the tree and you code with the help of the tree. It's 7:41 now. I'm giving you guys 2 minutes if there are any doubts with regards to this code, and then we'll practice 2 or 3 more questions using this method. Okay, someone's asked for the working of ABC. Okay, let's see how the working of ABC works. I'll show it here only. You know, this is a little difficult to do without a blackboard, but okay. Now, your basic concept again is this, that you take the output string to be an empty string and the input string to be ABC. So you take, I'm just going to, you know, do as well as I can here, and your input string is an ABC. Okay? Your first step is going to be when we analyze A. So either we choose to include A or we not include A. If we don't include A, we get a BC. If we choose to include A, you get an A followed by a BC. Alright. Moving forward, we go to the left, this part again. Okay, you just imagine this to be a tree. I'm trying to, you know, do it as well as I can using an editor. Now our analysis is performed on B. Either you choose not to include a B and your input string becomes a C, or you choose to include a B, in which case your input string again becomes a C. We perform the same analysis on this now. That is, either I choose to do not include the B, in which case I get an A followed by a C. Here I choose to include the B, in which I get an AB followed by a C. The last step of this tree is going to be the analysis of C. Okay, how do you perform the analysis of C? I'm using this. Either I choose not to include the C, in which case I get an empty string and an empty string. Here I choose to include a C, in which I'm getting a C followed by an empty string. Now I move to this. I either don't include the C, in which case I get a B followed by an empty string. Then I choose to include the C, in which I get a BC followed by an empty string. Now I'm going to analyze this. Either I choose not to include the C, in which case I get an A followed by an empty string. Now I choose to include the C, in which I get an AC followed by an empty string. Moving on to this. Either I choose not to include the C, in which I get an AB followed by an empty string. If I include the C, I get an ABC followed by an empty string. So let me just make it look more like a recursion tree. So now this looks more like a recursion tree. Yeah. So you go from here to here or here, then you go to here or here. This, you can see what the recursion looks like. And if you see here, you get 8 outputs, 1, 2, 3, 4, 5, 6, 7, 8. And when we solved this question also, we got 8 outputs. So I hope that Gautam has been able to understand how the recursion works. It's 46. I'll give 1 more minute for doubts on this question and then we'll move to the next one. Okay, great, Gautam. You were able to understand. We'll move to the next question. Another question which we will solve using the recursion tree method. It's a very famous question that you will see at a lot of places. I think LeetCode places it as an easy medium question. So it's called the permutation of spaces. ठीक है. So what we basically do here is we take ABC as our input and we take ABC. What you have to do is you have to permute the spaces, that is you have to put the spaces in as many places as possible. Either you can put a space here, you get an A space BC, or you can put a space between B and C, that is you get an AB space C, or you can put a space between both A and B and B and C. The most important thing that you have to note here is that you do not put a space before A and or after C. So the choice that you're basically making here is, do you include the alphabet with the space or without the space? But another exception to this is that your recursion tree is not symmetrical. It starts with a single line, because when you analyze the first character, you are always just putting it as it is you're not allowed to put a space before that character. So when you analyze the A, you get A as the output and BC is the input. Okay. After which you go to the analysis of the next alphabet. Here you can choose, either you can take a space and B, or you can take a B without the space. So you get an A underscore B, an A space B if you choose to put the space, and your input letter becomes C. Or you can put it without the space, in which case your input letter becomes C again, but you get an AB instead of an A space B. Following the recursion tree from there, you get an A. If you choose to take, now we're going to analyze the next alphabet, which is the C. Here also there are two things you can do. Either you can take the space C, or you can take a C without the space. If you choose to take it, in every case the input will become an empty string, because this is the last letter that you're analyzing. If you choose a space here, you get an A space B space C. If you choose no space here, you get an A space B C. Similarly, if you do the same thing for AB, you get an AB space C, and if you do not choose to take the space, you get an ABC. So you've gotten this recursion tree has helped you get these 4 outputs that were actually required by this question. How do I code this is the compulsory question here. Again, I'm going to use very similar methods. Once you have the recursion tree, it's going to be very easy to write the code for this. So you def solve input comma output. Again, if the base generally remains the same, that if the length of input is equal to 0, you print the output, after which you return. Now if you analyze the recursion tree, here you are, when you take the outputs, there is something to be noted here, that we're starting the recursion tree from here. This single line that is there will take care of this in the main code. So we're starting from here, okay? So the thing that you have to essentially do is, either you have to make the output the next alphabet with a space, or the next alphabet without a space. So again, you divide your output into 2 parts. Output 1 becomes output plus empty space plus input of 0. Output 2 becomes output plus input of 0. So this is the first one. Output 1 is with the space, output 2 is without the space. Similarly, you make the input smaller. That is, you have decreased the input by 1, after which you solve Okay, so this part essentially remained the same. The only thing that you had to change here was how you were specifying the two different outputs. One more important thing that has to be changed here is going to be in the main code. Once you have taken the input string, you have to automatically decrease the input string by 1 in length, as you can see here, and you have to add the first digit to the output. So the output, instead of being an empty string from the beginning, is actually input of 0, and the input is okay, after which we can solve for input comma output. If I try to input ABC only here, you get an A space B space C, you get an A space BC, and you get an AB space C. If you want to see this more clearly, instead of a space, let me just give an underscore and show you guys. There you go. So this was a small variation on the last question, and what I basically was trying to show you guys is that you can do different kind of recursion problems using the input output method. Again, I gave it's 7:54, 1 minute to see if you guys have any questions with regards to this problem, and then we'll move to one more question. Okay, if there are any issues, network issues, you can watch the video at a later stage. The video will be uploaded on YouTube. Okay, I had a couple more questions planned, but due to the time constraint, we'll just do one more question, after which it's all about practice for you guys. The next question that we do, these are again very famous questions which we're practicing here. It's called permutation with case change. What you basically have to do is you have to print the same set of letters. You have to print a string with all permutations of cases that are possible. The input that I've taken is very small, so it's very easy to do it here. Either both A and B will be in small, or the A is in small and the B is capital, or the A is capital and the B is small, or both of them are capital. How do you do this? You take an empty string as an output, you take AB as your input, you give it two choices, either you go in small or you go in capital. Decrease the input by 1, again you give it two choices, either you go in small or you go in capital, and the input, you do this until the input becomes the null string. So since we've already, we won't waste a lot of time in this, we will simply start coding, because these are similar questions and not something that you have to worry about. This remains the same, that if the length of the input becomes 0, you print OP and then you return. What changes is this: the output is either the alphabet in lowercase, output plus input dot lower, or it is output plus, input of 0 dot lower, one string, 0 dot upper. After this, you decrease the input length by 1 and you solve for input comma op1, input comma op2. Here, since there is no initial step, you initialize the output as an empty string only and you solve. Let's do it for a bigger set of alphabets. There you go, you get all permutations that are possible. That is again 8 in this case. You can these questions were basically only to make you guys understand how the recursion tree works. You can move on to higher level questions from Geeks for Geeks or any other platform that you would like. If there, will wait till 7:58 or 59 if there are any doubts.